I am a regional champion for the Great Science Share and a regional mentor for the Primary Science Teaching Trust. Tonight we're going to be looking at how can maths support children's experience of the Great Science Share, and we're going to be really looking for those mathematical moments that can inspire children's science inquiry and also deepen their understanding of science. Without further ado, let's carry on and think about how maths can actually further our understanding of science inquiry or actually inspire us in our questioning. This little GIF that I've made here is from a Great Science Share event that I ran a couple of years ago in Suffolk, and the children's question came about because they had chickens and they wanted to know how strong eggs were, and none of us knew how strong eggs were until they actually started to investigate this for themselves. And as you can see here, they started to work out by putting lots of different weights on the eggs, and they were able to come up with a calculation. So actually they wanted, the maths for them was about quantifying the strength of an egg. Everybody tells you an egg is strong, don't they? But how strong exactly is that? That's the thing that we don't know. So this is what they were investigating. And this is what I wanted to talk to you about tonight, really, how maths can really deepen our understanding of scientific ideas, and also how mathematical facts and information can actually inspire children's inquiries, because that's the point of the Great Science Share, isn't it? It's this wonderful moment where children ask a scientific question, they carry out their own investigation in whichever manner is appropriate, and then they communicate and they share their findings with each other and with wider audiences. And that's what I think is so special about the Great Science Share, is that we have this moment to share and to encourage children to share about their learning. And so what we're trying to do today is look for the maths thread throughout that. So I'm just going to turn it. So Maintaining Curiosity, really old report, but it's a goodie, and there's some really good stuff in there, and it talks about the benefits of linking maths and science. And actually it talks about how when we give children real world experiences, it reveals things about the big ideas of science. And actually what maths does is it adds an extra layer. You know, we can describe the world around us through various ways, can't we? We can articulate through words. We can also use number as well and maths to explain the world around us. And we can use the arts as well to express what we see. And I think what we're trying to do here is look and just check that actually we are using all the languages available to us, the language of words and the language of maths, in order to heighten children's understanding and to allow them to really communicate and find out and explore these ideas in a rich as way as possible. That's where we're going with this. By doing so, what we actually promote is mathematical fluency. And that mathematical fluency, I think we have that desire actually for our science learning too. What I mean by fluency is seeing a problem, working out the possible ways of dealing with it, of answering that problem, breaking that problem down into the steps that you need to work through in order to answer the problem, collecting and analysing and presenting that data and thinking about what it means. Or is that not very similar to the scientific method? Are they not walking really hand in hand? And so actually by connecting the two, we develop not only our mathematical fluency, but also our scientific fluency as well. And I think that's why this is such an important pairing. Science gives you an opportunity to utilise mathematical ideas, concepts and skills, and to embed them into a real context. But the maths gives us a depth to our scientific investigations that really allows us to understand it on a deeper level. So that's why I want to link maths and science as much as possible. So this is a great Science Share webinar, and of course I want to talk about questions, because they are at the heart of children's inquiries. They are at the heart of what we do with the Great Science Share. And as we go through tonight's presentation, I'm going to identify the different types of inquiry that we'll be covering. And also I'm going to identify some of our themes, because actually in May, we're going to release this year's themes. The weekly themes are a great part of the Great Science Share Toolkit. And each week there is a theme that's announced, and there are resources that underpin and support that theme that will inspire you and your children to go out, get stuck in, and to lead some inquiries that then you can communicate about in the Great Science Share in June. Also, just want to flag up before we move on, the Great Science Share Question Makers resource. I love these resources. They are just gorgeous. They're really beautifully made. They're PDFs that you can download. They are fantastic for scaffolding and supporting children as they come up with their own questions. They're also brilliant, not just in science, but actually curriculum wide. They're so lovely because they're very generic. So actually they could be used in any context. And they're just good for children who just need that scaffold and a bit of support to come up with their own questions. So do have a look at our amazing resources, because they're free and they're accessible for you to download. Now, I know my audience here with me live today, I know some of you are practicing in the classroom, some of you are consultants and advisors, and so these are things that you could perhaps share with your audiences far and wide. So we're going to just think to start with about how questions can, how data can stimulate questions, how they can inspire our thinking. I'm going to start with, what about giving children some data? Often we don't do this. Often we ask a scientific question and we go through an investigation and then we gather data, and it's the bit that happens towards the end. Well, have you ever thought about sticking it more at the beginning? Because actually it can be a really inspiring way to begin inquiry. So a couple of years ago, I was teaching a Year 6 class, and we were asking questions about the big Schools Birdwatch, which comes around every spring, doesn't it, in early spring. And we had a look at this data, and we were seeing that actually the most common bird in UK gardens is the house sparrow. And we were saying, well, that's not what we see out of our classroom window. And we had a bit of a discussion about it. What did we see? Well, pigeons, seagulls. And then we thought about our habitat, actually of our playground. So it was an urban school, not much space outside. It's either covered in astroturf or tarmac or concrete. And we were like, well, why is that then? And then we thought about maybe the rubbish that was around as well. And we sort of started to think about that. I was thinking, actually, probably why we see more seagulls and pigeons about. Maybe it's this, maybe it's something to do with that. So it got us asking some quite big questions. And of course, when you look at what's lovely about the Garden Watch data is that it goes back to 1979, and you can see on this slide, the general trends of house sparrows, starlings, robins and blackbirds all actually have declined in numbers since 1979, which is quite a saddening statistic, really, isn't it? So it really got us thinking, this information. Now this year, actually, there was a BBC Live lesson on the big schools live lessons on the BBC, and it was connected with Winter Watch, and it was looking at the big bird watches that happen, and there was a link to the RSPB. That's still available for you to look at, and there are resources on the BBC website as well if you're interested. So what did this really mean for my children? Well, here we are. Here's some old tweets that I found, because I've moved on from the school, but we can still get some pics from Twitter, which is great. So the children started by learning to identify some of the common garden birds, and they did some. It was year 6. We were working on classification, so they started to generate their own classifications, and they came up with the Venn diagrams and the Carroll diagrams and ending in dichotomous keys. That taught us to look at birds and to start to think about the important features, the beaks, the feathers, the colours, the habits, and the diets and that sort of thing. So they started to become familiar with that. Then they were like, well, hang on, miss, we haven't got that many birds in our playground. So we started to look at, well, where else have we got? So we realised there was a quiet spot actually over by the staff room, started to put up bird feeders. They made some questions, they were driving this all the way through, deciding what sorts of bird feeders to make, where to site the station, and then we worked out that we could spy on the birds very, very well from the staff room. So the staff were very, very good, and we got to sneak in there and do our bird watch. And this was a whole classification unit. So what I'm saying is that from data came inquiry, and not just one inquiry, but several inquiries. And that was the point. And that's what we're doing here, is we're using data to inspire learning going forwards. So data is one starting point. So rather than at the end, it could be the beginning of a journey. All the bird watches, the school's bird watch, the garden bird watches, are citizen science projects, and actually there's loads of citizen science opportunities out there. The Imperial College London ran the Opal surveys. They ran actually from 2007 to 2019. However, the website is still up, and there's loads of different surveys that you can actually take part in. Over 1 million people have done these surveys over that time, which I think is a staggering number, and giving scientists actually data that they wouldn't have access to in any other way. One of them is the earthworm survey. 5,500 people took part in this, and the stuff is still there, so you can download a really nice guide to worms, so a really easy key to help you to identify, and there's advice on how to do a survey, and more of that is coming in the next couple of minutes with me. So earthworms, now this is the thing, you see, you take children outside, what's the first thing kids always look up or look for? Is they start digging, don't they? They find a worm, they bring, I found a worm, miss. It's the classic, isn't it? It's the first thing that children look for. So worms are always a good one, and they come up, or they inspire lots of lovely questioning. So obviously there's the identifying, classifying of worms, which is great. There's also the way that you get your worms together. So what about worm charming? So worm charming is attracting the worms to the surface of the soil. I thought I'd have a go. So I'm going to play you a pretty naff video of this. I'm just going to stop my share again, and actually I'm going to reshare because I just want to optimize for the sound, because I forgot to do that earlier. Sorry about that. Here we are. So I'm going to play you my little video of me worm charming. I'm also, after this, we go into a conversation with my friend David Purdy, who he works in the agricultural industry, and one of his passions is soil science. So we're going to, you'll find that the film goes straight into that.
We're going to try and charm these worms and see what difference some vibrations and some water makes. Because I'm overexcited, I'm going to do both at the same time. If you're doing this with your children, you could try just vibrations, or water, and you could kind of science that one up a bit. If you wanted to mathsify this, we could even use quadrats with string squares on, so you could start to do fractions of coverage. I'm not doing any of that. We're just going to try charming those worms. So first you water the ground, then you jump on the ground, and then you wait a while. So, I had lunch, I waited and waited and waited. Nothing happened. The rain didn't work, the dancing didn't work. The thing is that worms will come to a vibration. So, I did some research, I have a new method to try, and this is hitting a fork, which acts like a tuning fork in the ground with my hammer, and we're going to just give it some welly and see if that works. Have you seen this? Look, they said it wouldn't work, and it has. Look, this is my big earthworm. It just suddenly popped up. Look at that. Absolutely huge. Just brilliant. Oh, and that was from twanging with my garden fork. Fantastic.
I'd like to introduce you to my friend David Purdy. David is a soil researcher, and I'm just going to ask him some questions because obviously we've had a lovely time thinking about worm charming, but what's the point? Because surely there is someone somewhere. So, David, why are worms important?
Thanks, Claire. I've spent a lot of time trying to answer that question, and in terms of agricultural context or even soil health, worms perform a lot of functions, and they provide a thing called porosity within our soil. They provide lots of channels as they channel and burrow down into soil, and that gives opportunities for roots to go down those channels, opportunities for water to go down into those roots, so in those channels. So it increases the amount of water that a soil can hold, for example. It provides, they actually consume soil, and what they excrete is very rich in nutrients. So they're kind of typically that mittens we call that often sits on top of the soil might hold 7 times more phosphate as an example, and as many other nutrients it holds as well, which then can be later consumed by the plant and provides nutrients in a form that the plants immediately kind of take up, so we don't have to apply chemical forms of nutrition to the soil. So they're very, very important. They're good indicators of the health of our soil. We can easily measure them, and they provide lots of good functionality to our soils, and very importantly to our plants as well.
Brilliant, thank you. So why do you count them? When you're looking at soil health, why do you count worms as an indication of how healthy the soil is?
I mean, soil health is a very difficult thing to absolutely kind of just define or measure in a very well. We're dealing with complex ecology. Ecology by inherently is very noisy, and so we're looking for indicators that would suggest or show us how healthy a soil is, and worms is certainly one of those. They're very responsive to different things we might do in soil. So if we might grow a plant in soil, you get a lot more worms around a plant root than you would do where there's no plant growing. But if you move a lot of soil or disturb a lot of soil, so you dig a lot of soil, in agriculture we might plough a lot of soil, you will decrease worm numbers. So they're very responsive. So they're a good indicator. So therefore, if we measure them, we get a fairly good idea of health, certainly the biological health, which is arguably one of the more important areas of our soil health, are often neglected, but the biological health of our soils.
So you said earlier that to me that about 20 in a spade's worth of soil, a good number of worms would be about 20, which is a real. I think that's quite an interesting statistic for schools to maybe compare their own soil health against, actually. But if you were surveying and looking at worms, what are the sorts of things that we should be bearing in mind, or what sorts of things could we be doing with the children to survey worms?
So I think the first time is just to recognise the times of year when you can do that and times of year when you can't do that. So if you go out into soils when it's very dry, So in the summer periods, you can probably dig a lot of holes and you won't find a lot of worms, just because they follow moisture. They need moisture to survive. They can't move through soil without some degree of moisture in it. So you won't find any worms. So you could suggest that soil will be very unhealthy, but that would not be the right way or interpretation of that. So you have to go out when there's moisture around and some warmth as well in the soil. So generally speaking, we say to people around about kind of mid to late autumn, and then sort of mid to late spring. So March is an absolutely fantastic month. Late February, early March, mid-March, depending on moisture, it's a great time to measure our worms. And yeah, we take just a normal spade. I mean, obviously spades come in different sizes, but we don't get too hung up about that, but just a normal spade full of soil. Try to be consistent about how you dig that soil. And then something about a really healthy soil will probably have something between 16 and 20 worms, but you can measure up to 60. You know, in some environments, depending on what you're doing, you can have 60 worms in that spadeful. That's probably right at the top end. And in some environments, you might get only 1 or 2 if you haven't got a plant living in that soil, or you've disturbed it a lot, as we do in agriculture, for example. You might only have 1 or 2 worms. So you can have vast extremes, if you like, and lots of variability, but a good number to work would be somewhere 16 and 20 would indicate something that's healthy is going on in that soil, I would suggest.
Brilliant. Thank you. So if a school wants to improve their own soil health, what should they be doing?
So fundamentally, the building block of soil health is carbon, and that's quite a complicated word. We might know it's organic matter or something like that. But if you want to improve the health of your soil, then quite simply, you know, either add carbon, and you can do that by adding, you know, things like manure into the soil, or you can add carbon by just having a living plant in your soil. So that plant, what we call photosynthesizes, and it dumps carbon into the soil, and that's like a carbon pump. That's the way we get carbon out of our atmosphere back into our soil. So a couple of simple ways of adding carbon to the soil, and whenever you will add carbon to your soil, you will almost inherently increase things like worm numbers. So that's a good indication that you're moving that soil in the right direction, shall we say.
Brilliant, thank you. So there's actually some real potential there for some long range school investigations around soil. Thanks, David, for your help. So the thing is that this is something cheap, easy to do, but actually has got real merit, because actually with introducing children to worms as an indicator species, you can measure worms. That will help you to identify the type. It will also help you to identify where the worms might have been living, because the very long worms, the one I found, actually they live deeper in the soil. We tend to get the shorter worms in the top few centimeters there. So there's loads of maths, and you can do long range studies, like we've said, of your soil health. You can even try and work on the soil health and then come back and repeat that investigation to see what the impact is. So I actually think from somebody just bringing you a worm, there's a whole load of learning. I think what we need to do as teachers is to embrace those moments and to actually see the potential from a conversation or a moment that a child has, because often we kind of carry on with our discussions and we leap past them. But actually what we're doing here is we're taking that worm and that moment with that learner, and we're allowing the science to then happen from that child initiated moment. And that's what we really want to see in the Great Science Share, is those child initiated moments built on, capitalized and embraced, so that children really can get stuck into their own science. So other things about being outside that are totally inspirational, the shapes that you see. And again, this is a moment, isn't it? A mathematical moment where actually we're taking the ideas of shape that we've looked at in the classroom, but we're seeing them in the world around them. At the moment, I'm always obsessed by bracken in the spring as it pops up in that amazing little tiny spiral. It blows my mind actually every time, that perfect little spiral that you see in the spring. But it's not just the only place that you see that, is it? It's not just in bracken and ferns, it's also in things like pine cones and sunflowers and Romanesco. That's my posh veg, but I literally buy Romanesco because of the spirals, which is a bit sad, but they are just enchanting. But how awesome, because they are directly related, or you can see the pattern in the Fibonacci sequence. And the Fibonacci sequence is there all over the natural world, even including how things reproduce as well. I love this book called Rabbits Everywhere. It's a Fibonacci tale. And there's lots of lovely stories out there that you can find. There's by all sorts of different authors. I think Emily Gravett has one as well, which again allow children to explore Fibonacci in their natural environment. And questions will come from just exploring that. Where do you see a spiral? And suddenly they're looking everywhere. And we actually did a project about this a few years ago, and it turned into the most beautiful art project as well. We did loads of printing, all inspired by spirals in nature. So it's just taking those moments of the natural world and kind of going with them. Snails is another example. So did you know that a lot of snails are righties? So their spiral usually goes in a clockwise direction to the right. And actually only 1 in 40,000 snails are lefties. Who knew? I certainly didn't. But is that true? What a great mathematical nugget. But how lovely to then explore that and actually see if that's actually, you know, if that's true. And children love to look for snails, don't they? And again, it's another way of just exploring, deepening our interaction with the world around us. I don't often get to look at the chat when I'm presenting, but I can see that Liz Thomas has got a lovely book called Growing Patterns. If you know any other books that you'd like to share, please pop them in on the chat, because we'd all like to know. We'll all be on Amazon afterwards. Brilliant. So yeah, it's just taking those mathematical opportunities. I wonder what you think you could investigate around snails. Where's the maths? If you've got any ideas for this, please pop it into the chat, and we will have a look at those in a moment. So if you've got any ideas around just enjoying snails, any inquiries that you've done looking at snails, and where the maths is in there, that would be wonderful just to share with each other. Wonderful. We will carry on whilst you're thinking. Sometimes it's just lovely to give children a mathematical fact. I really like these books by Steve Jenkins. This one, Biggest, Strongest, Fastest, but he's written loads. This one's on dinosaurs, prehistoric actual size. I love the hyperbole of that. A flea can jump 130 times its own height. What an awesome, awesome fact. Worth doing a bit of work with children actually about whether you can trust the fact. Is it real? Is it true? If it is true, I think it probably is. I did a bit of fact checking myself. I think it probably is true, but that's a nice way to start with research, is to fact check and get the children to find some sources that actually support what they've read. So that's a really good use of research in order to do that. But from that research inquiry comes other inquiries, practical inquiries. But just going back to the flea thing. So if I was a flea, I would be able to jump 21,450 centimetres, which is 703 feet, just to get an idea of how far they can jump. This is honestly, my head is just blown by this. 54 elephants high, or 4.2 Niagara Falls. I was like, oh, is that all? Niagara Falls can't be that big. So then I looked at Victoria Falls. I could jump 2 Victoria Falls, which felt better to me, or 2/3 of an Eiffel Tower. Now you see, that's exciting, isn't it? Because what you're doing is you're taking that little bit of ratio of how high that flea can jump, and then you're looking at yourself, and you're just starting to play with number. And I think this is the thing. We need to make number become alive. And actually, by living and breathing and exploring and walking around these facts that we just glibly read, don't we? Oh, here, child, here's a non-fiction book, and they read them. But actually, if you take a minute and really enjoy the facts and actually walk around in them, how rich is that as a learning activity, and inspirational really, isn't it, for just encouraging that thought. Yeah, thank you. Growing Patterns by Sarah Campbell. I love numbers. Oh, and I love Animals by The Numbers and Actual Size by Steve Jenkins. We have been investigating jumps for humans versus animal jumps and comparison to body size. So Liz has got a whole range of inquiry there, all inspired by this book. And I think that's the point, isn't it? Is that, you know, just one little set of facts and number facts inspires a whole raft of scientific inquiry. And that's what the Great Science Share is all about. It's about that inspiration and about that curiosity. Speaking of curiosity, we have curious creatures, the tube-lipped nectar bat. Now, this one made me chuckle. So his tongue, or its tongue, is 8.6 centimetres long, but his body is only 5.8. So he has to coil that all up, and it's so massive that he has to store it actually beneath his rib cage. Now you see that suddenly when you start to actually look at it in real and actually get a tape measure out, and then you start to really think about that, is that not really A, hilariously funny, and B, really quite incredible? And it's finding those nuggets, isn't it? And then getting children to really make them real. So actually getting some string out or some tape measures and actually measuring these things out. I was very inspired this afternoon by a Gigantosaurus. Now, I was very fortunate to see a skeleton of one in America a couple of years ago. But chalking this stuff out onto the playground, just looking and learning to appreciate size, because I think our understand, you know, we see numbers, but it's about making them real. And actually, I think by taking those opportunities to actually go and measure that and see it and feel it and experience it, gives us a better understanding, I think, of number. And that's, I think, one thing that science can do is make that kind of conceptual stuff more real and visceral somehow. I love trees. I'm a real tree hugger. So here's a little film where actually I wanted to go and measure a tree on the park near me. I've done this lots with children. This has really brought measuring to life, but it's also really helped us to understand the trees that in our area. So I'm just going to play you this little film just to explain really how you would do that. Oh, so sorry. So there you are. So there's some just basic ecology really of how to measure the height of the tree, how to work out the age of the tree, using some simple maths there, which children can do really easily. You can buy clinometers and use that as a method for measuring the 45-degree angle, but actually staring through your legs and shuffling along kind of equates roughly. There's other methods, and actually this is another thing that I've done with children, is got them to compare different suggested measures, ways of measuring the height of the tree and deciding which one's most accurate. So actually not only are they using the maths to work out the age of the tree, but they're also weighing up the merits of different methodologies and actually looking for accuracy and having discussions around that as well. When I've done this work with children, we've used the tree data to actually understand the local history of where we were, because the dates that trees are planted, sometimes it tells you when a place became habited, and it sometimes tells you a little bit more about the area that you're looking at. Oops, sorry, we'll carry on. Another way of looking at maths outside, just an inspiration, is actually to look at rubbish and decomposition, because the thing about as humans is we're a grubby lot, aren't we? And historians actually will often dig up rubbish dumps and tips, and they will see human detritus which just hasn't decomposed. Things take longer to decompose than we first think. I think decomposition is really interesting because it's a window into materials actually, and about actually what they're made. It helps us to think about what materials are made from and their longevity, and actually maybe our human footprint on the earth, which is a really important thing for us to think about in our ecological crisis. So I quite like decomposition as a thing. In a moment, we are going to send you, not yet, but we are going to send you to a Jamboard. And on this Jamboard, I've just got a really simple, we're going to put you into breakout rooms. The breakout rooms are so you can have a chat, and the Jamboard is so that you can work together on this activity. The idea is you're just going to drag these, it's going to take moments to do. You're just going to drag these squares with the different items of rubbish and just decide as a group which ones you think are the fastest to decompose and which ones are the slowest. So there'll be a sort of continuum. When we put you into your breakout room will have a number, and this will be, you see it on the breakout room when you're sent. When you're sent, you're invited to go, and you just have to press the button and follow the link. We will call you back automatically, so you don't need to do anything there. The Jamboard, you'll have that up in a separate tab to the tab you have open for this webinar, and the link is in the chat, and we're just making sure it's a good idea if you open your Jamboard whilst I'm chatting to you, because the minute we send you to the breakout rooms, that Jamboard link isn't available after that point. So that's really important. If you have any problems, don't worry, because I will have it open on here. If I just stop this share and I just go to the screen for the Jamboards, I'm just going to show you that here, you see this box where it says 1 out of 15. If you scroll here, each breakout room will have their own Jamboard for this little decomposition thing. And if it's something you like and you think, oh, do you know what, I wouldn't mind using that, if you go to the 3 dots, the more actions, you can actually copy these or save the frame as an image, and then you could actually do it yourself. Or you can actually, if you already have Jamboard, you can copy a Jamboard, make a copy, and then utilise it yourself on a later date. So welcome back, everybody. I hope that was fun. We'll have a look first of all at what the answer is, because there is an answer, and then I'm going to ask you what inquiries, how you might take this into inquiry, and what you think the children might come up with. So here is the answer. This is a time taken to decompose. You can get this from Practical Action, this resource. So we're going from a tea bag, which only takes a month, to an apple takes 2 months, woolen sock a year, plastic bags 20 years, plastic bottles 450 years, and a mobile phone over 1,000 years. Now, I think that's really interesting because we bandy about these numbers, don't we? But actually, if we put this in context, say I buried, I don't know, a mobile phone, no, plastic bottle, for example. Well, 100 years ago, what were we doing? Well, the suffragettes were campaigning for women to have the vote. And it would, so if they buried a plastic bottle, which they didn't have, obviously, but 100 years ago, it would have taken all this period of history, all this stuff would have happened, 2 world wars, pandemics, the 60s, all of this stuff. And I think it's worth trying to kind of look at decomposition and put it in kind of historical framework so that children start to understand time. Time is such a hard one, isn't it, to get your brain around? And I think it's really interesting to look at decomposition, to actually explore it in your school grounds, but also to maybe put it against history. 500 years ago, this was the time of William Shakespeare. So all that length of time from William Shakespeare all the way through, it's mind-blowing, isn't it, quite how long these things take to decompose. So it's quite incredible. My question to you is, and it'd be lovely if you pop your mics on and just share with us for a moment. I'll just stop my share actually. But what would you do? How would you, what sorts of inquiries do you think might come from this starter about decomposition? Liz, would you mind sharing what you were just talking about and how you thought you might develop decomposition? Because that was really interesting.
We sort of talked about possibly just taking one of the themes, so perhaps just taking different types of magazines, or comparing apples with bananas, but looking at if we had the same sort of surface area on the apple as on the banana, would it make a difference? So we're looking at mass and time, but different habitats as well around school and different sort of conditions.
Yeah, that's fantastic. And I think the different conditions is really really interesting because it slows down decomposition, doesn't it? We have in the chat here, we have a message from Karen. She says, I tried this out, buried all these things in September. We're about to dig them up next week. They wrote down questions when we planted it, and we will have a look and answer some of those questions in a week's time. That's gorgeous, because that's a really lovely long range science inquiry. I love that, because it's just there, isn't it? And I think there's such potential, and also there's such a link, isn't there, to climate change and climate management, and just how we are custodians of our planet. So I think it's a really interesting thing to explore, and I know that children have lots of questions from something as simple as the compost heap or decomposition and looking at trash. So just moving on, I wanted to flag up these lovely resources from the Polar Explorer Education Resources, actually still developing the ideas around climate change. I love this stuff. So we've got some beautiful images from space looking down onto different, this is the glacier, the Columbia Glacier, and you can see these are photographs over time. And what you can see on this glacier is the recession as climate change has taken hold of the glacier, how it's receded back and back and back. We can get such a lot of maths from this, can't we? Because we can be looking at percentage cover, we can look at ratios, we can look at fractions. You know, it's full of mathematical moments and possibilities. We can use this as a starting point for looking at what does climate change really mean? What does global warming really mean? Actually, what's the relationship between this notional thing that you hear about on programs like Blue Peter, or you know, the Blue Planet or whatever, and actually, but what does it mean? What's the reality? And I think these maps really start to bring that home. I know children have so many questions about our planet that they would love to explore, given support. And each week when we release our resources in May against our themes, have a look out for the Clean Air Week particularly. I was inspired to think about ice. That was kind of where my brain went with this. And started to think about, okay, well, what if I just even simply have an ice cube and we have it on two different colour backgrounds? Which one melts the fastest? Now, I would have done this with you, but it didn't seem that practical really on a webinar. But I have done this a lot with students, and it's looking at the albedo effect and the idea that actually the dark surface, so as the land loses its ice cover, and the ice cover is white and reflective and it's bouncing back the solar radiation, isn't it? And so actually it's not going to melt as fast as the darker surface, which absorbs all that heat from the sun, and so therefore it's a kind of, it speeds up the process of actually the receding ice sheets and actually the problem of the glacier receding. So it's a really exciting way to kind of start with something like the maps and the pictures of the glaciers and the photographs, and to look at where the glacier was in certain times of history. And somebody just very rightly pointed out in the chat, there's some really lovely graphing potentials there, and actually predicting potential then, because if you're looking at percentage coverage in 89, 2005, 2015, you could start to then maybe think about, well, how much glacier do you think will be left in 2022, 2030? And actually you could start to make some predictions there, couldn't you? But bearing in mind the albedo effect, which actually says that the more dark land you've got, then the faster that ice is going to recede. So we're getting into some quite meaty stuff, aren't we? But starting with a really beautiful picture stimulus there. And there's it's just replete with maths potential, really. This PowerPoint, by the way, we will make this available to all of you, and we'll put it up on the website so that you can have it and you can have all the links. So do feel free to come back to the website, or even just to email me and I would pass it on. My other favourite mathsy thing is data loggers. I love data loggers. I use them all the time. Now, I have to confess, I'm a bit of a technophobe and I hate having to wire things up, and you can bet your bottom dollar that your program will not be the program that links with your computer. You know, these things never marry up. So I tend to use data loggers. I know probably my friends at Data Harvest would want to shoot me for that, but I tend to use them a handheld device because I find them much easier like that. What you get on a data logger is you get internal thermometers, you get light meters, you get decibel meters, you also get probes that you can stick in as well. I find these really brilliant for adding mathematical layers to outdoor exploration. So, for example, the ivy in my garden, I've got this beautiful ivy, it's been there for years, and but I can see that the leaves at the bottom of the ivy, I mean, obviously the ones at the top are newer, but even so, if I come down even a little bit, actually, they're still smaller, you know, and even though they've been there for quite a while, it's been covering my wall for several years now, 10 years or more, they're still smaller than the leaves further down. So why is that? So I went outside. I have nothing to do with my life, it's lockdown. So I measured the leaves of my ivy, and you can see I got some little averages there. And I thought, well, that's interesting, but what's the point? Why would you have a bigger leaf at the bottom of the plant and smaller at the top, other than the new growth, which I wasn't counting? So I got my data logger out, stuck it in the ivy, and this is the difference in the light level. So obviously there's loads more light at the top of the ivy, of course there is, and you can see this beautiful figure, 53,081. Loads more light, whereas at the bottom it's 711. So of course, if a plant is to capture the light, it's going to need to have bigger leaves, isn't it, at the bottom of the plant? And this is a classical sort of ivy thing, isn't it? The smaller leaves are nearer the light. But this sort of investigation, adding this layer of complexity, adding the data loggers and having them there as a handheld device, gives children a broader spectrum of numbers to investigate and to engage with, and it also allows them to kind of understand what's going on horticulturally with that ivy as well. So that's why it's really useful. So I'm going to speed up a bit. We were slightly late starting, but we're nearly at the end. So adding challenge to inquiries. Another thing that you can do is sometimes you can just add a mathematical challenge. So children have got an inquiry going. So for example, could be bottle rockets. You know, you fill them with water, you put them under pressure and they zoom off. We can play with that amount of water, can't we? We can add it an extra 20%, see what the difference is. We can decrease water by 20%. We can just, and you can again start to utilise the language of your maths lessons within your science lessons to add that element of challenge. And I think that's another way of just pushing the exploration just a little bit further. So just your moment for reflection, really. How do you seize those mathematical moments? So when you're exploring scientific ideas, do you talk explicitly about the maths that you're using and that the children are using? And do you talk about the benefit of using maths? We began this by saying that there were two kind of languages really for science exploration. There was the vocabulary and the words, but there's also the mathematical language of number and of those measurements. And actually that mathematical language can really deepen our understanding. We talked about how we wanted children to be fluent and excited and able and confident to use both of those languages, so that they would have this really holistic, big view of the science that they were exploring. So I just wanted you to kind of think about your own practice, really. And I was just wondering, when your children are planning their own scientific investigations, which we know that they will be doing, do you take a moment to really get them to think about how they could use maths to find the answers, to deepen their understanding, and actually have that positive maths chat that would just widen and deepen their inquiries just a little bit further? So I'm going to stop there. It's time for tea, but I am here to answer any questions that you may have. And I think we are about to come to a halt. I can see lovely Lynn Bianchi there from the Great Science Share. Nice to see you, Lynn. Thanks for joining us. There is an evaluation poll thing. If you'd like to give us some feedback, we would love to see it. So thank you for that.
Thank you, Claire. I apologise, I was late. There's lots going on with Great Science Share at the moment, so we are spinning plates, you might say, but I've caught the best bits. So thoroughly enjoyed. I know that we'd prepared anyway, so I was aware of what you were doing. Hope you've enjoyed it, Claire, yourself, putting this together.
Thank you.
About maths in context, it's certainly food for thought, something I wouldn't necessarily have done in my classroom years back, but it just is so, when someone says it like you, it just makes it so obvious. You think, well, why didn't I do that? Why didn't I make that authentic link? And I think this is so much more important now for children, connecting all of those different subjects together and making meaning out of it. So
we have a question. Oh, sorry, Lynn.
Yeah, no, go ahead.
Very quickly, from one of our, I can't see who did it now, but somebody was just asking about, is there a data logger that I like? I quite like Data Harvest. I equally like the ones from TTS. There's, to be honest, you might have to look around in your cupboards and find that you've got some that aren't being used from years ago. A whole load of IT money that came into school. We've got very excited and bought loads of data loggers, and because we're all scared of them, they're in the cupboard. So my view is, have a look and see if you have got any in your school that's just lying there in the mothballs, because actually if you just charge it up and you're not bothered about trying to link it with a computer necessarily, then actually it might be that that's exactly the right thing. Otherwise, you can add data logging stuff to your smart stuff, like if you've got any sort of handheld smart devices, iPads, those sorts of things, you can often get some data logging stuff to add to those. If not, then yeah, absolutely. I think any of those by TTS or Data Harvest are great for children. No particular view there. Sorry, Lynn.
No, I was just saying thank you very much. I think there's
my pleasure.
There's some apps as well, I suppose. If people have got iPads in school, I'm sure there might be data logger type of apps available as well, if you check out about, but I'm not sure.
McCann says that Science Journal is a good app. So that's a nice recommendation. Thank you for that. Thank you to everybody who's posted today with book ideas and thoughts and things, and that's really useful. So thank you for that.
Great. We encourage you obviously to get fully involved with Great Science Share. It's such an exciting year, I can't tell you. Steph and Kate working so avidly in the background, to bring an absolutely stunning portfolio of activities and brilliant people. So everything will become live on the 22nd of April. There'll be lots of information coming out. So now that we're back from Easter and things seem to be settling down, yeah, it's just going to be a really exciting time in the year. And so we really look forward to linking in with you.